This wasn't in the textbook, but it should have been. Hi everyone, in the previous video we looked at how to solve some quadratic inequalities. We looked at drawing a sketch, and today we are going to look in today's video on how to solve problems involving quadratic equation and equal roots. So we're given an equation with a variable k, and we need to find out for which values of k the roots are equal. Let's start by simplifying and applying some algebra techniques. So first off, we are given the function of x times a half x plus 2 minus k squared. So let's start off by multiplying or distributing the x on the left hand side so that we can get it into the form of my standard quadratic equation. So let's start off. So I'm multiplying in my x value, so I will have a half x squared plus 2x equals negative k squared. So all I did is I distributed my x value or my x variable. Now I want to get this into my standard form, which is ax squared plus bx plus c equals 0. So to do this, I will then just add k squared on both sides. So I will have a half x squared plus 2x plus k squared equals 0. Now you can see that my a values correspond, my b value or variable is there as well as my c variable. Now we need to go and look into something quite specific, which is then called my discriminant, and the discriminant is then the inside of the square root of my quadratic equation. If you have a look at 2 videos back where we had to solve the equation using the quadratic formula, you should recognize the discriminant. So I have b squared minus 4ac. So what is important about the discriminant for this specific question is that they want me to find the values of k so that my equation have equal roots. So for that to be possible, I need to put my discriminant, which is b squared minus 4ac, equal to 0. And graphically, this will be represented by a quadratic function that looks something like this. So it just means that my quadratic function will turn only on one point of the x-axis. I will only have one root or two equal roots. And let's quickly solve this. So I will start by substituting in my b value, which you can see is highlighted there in blue. So my b value, let's do this in green here. So my b value is 2 squared minus 4, and my a value in this case is a half, and my c value is k squared, which is equal to 0. So all I'll do is I will start by simplifying and taking my values across. So let's first subtract the 2 squared on the other side. So I'll be left with negative 4 times a half k squared equals negative 4. So now we can see that the negative 4 that I have on the left hand side and the negative 4 on the right hand side, I can divide the negative 4 on the right hand side, and that will give me a value of 1. So I would have a half k squared equals 1. Now because I have the half on that side, I can multiply by 2 straight through, so therefore I will have k squared equals 2. Now I'm very close to solving my k value, and to solve this I will square root both sides. Once I've square rooted both sides, I can say that my k value is equal to square root 2. And now I have my value for the turning point on that function. So in this case, now we can look at the square root of both sides, and then we have our final answer. So let's quickly have a look at some key takeaways to recap. Always expand and simplify the equation first. Rearrange it into its standard form as we've done there. And then use the discriminant, which is b squared minus 4ac, to determine where these roots will be equal. and then solve the unknown variable. Thanks for watching. If you want more examples like this, make sure that you subscribe and drop your questions in the comments. Remember, the discriminant is your best friend when checking root conditions. See you next time. Now that you know, pretend it was obvious all along.